This lesson is parent functions. So we're going to talk about different functions that you've talked about from Math 1 to Math 3, and there might even be some new ones thrown in, or maybe just some you forgot. So our learning target is I can find key features of parent functions. Alright, so a function family is a group of functions with similar characteristics. The parent function is the simplest of the functions in a family. So you're not adding or subtracting numbers from stuff. It's just a very simple function. You must be able to recognize each of these functions along with their characteristics. So this is what we're trying to review, get back in your head, the different types of functions, the different key features that you can find, how to find them, all of that good stuff. So the first one we're going to talk about is the linear, because that's the first one you deal with. Alright, so a linear function looks like this. It would be y equals x, or f of x equals x. Remember, that's the same thing. It's going to be a straight line. Alright, when we talk about domain, that's all your x values. So we would say from negative infinity to positive infinity, because it goes left and right forever. Your range, that's all your y values. Once again, negative infinity to positive infinity, because it goes down and up forever. Your x-intercepts, so it hits the x-axis at 0, 0. Your y-intercepts hits the the y-axis at 0, 0. It doesn't have any extrema because there's not a maximum or a minimum. It just goes up and up forever and down forever. Okay, so this entire function is increasing. So we would say it's from negative infinity to positive infinity. And because it's always increasing, then you would not have a decreasing interval. In behavior, you may have forgotten this one. This one I'm saying the left side is going down and the right side is going up. So I need a little extra room for this one. This is what I would say. If I wanted to say the left side, I would say as x approaches negative infinity, that just means left side, f of x approaches negative infinity. That means it goes down. If I want to talk about the right side, I would say as x approaches positive infinity, all that means is right side, f of x goes to positive infinity, goes up. Alright. And then discontinuity. So that's any break or like a hole in the graph. And this one is a continuous function, so we would say that there are no discontinuities. Alright. Absolute value we talked about in Math 3. It looks like this with the absolute value bars. It's going to be a V-shaped graph. The domain would be from negative infinity to positive infinity. The range, it never goes below 0, so I would say it starts at 0 and it goes up forever. It has an x-intercept at 0, 0, because it hits the x-axis there. Also, the y-intercept is at 0, 0. Extrema. So I would say it has an absolute minimum at 0, 0. So absolute minimum. It's increasing from here to here. Remember, that starts at 0, 0 and then goes forever. So I would say from 0 to infinity. It's decreasing from negative infinity to 0. The end behavior, so notice the left side is going up, the right side is going down. So I would say as x goes to negative infinity, which just means left side, f of x is going to infinity up. As x goes to positive infinity, the right side of the graph, f of x goes to infinity up. That's all that means. And then there are no discontinuities because there are no holes or breaks in the graph. Alright, and then quadratic. So this was big in Math 1, Math 2, and Math 3. The parent function looks like this, or if you like using y, you can do that. It's a U-shaped graph. Okay. The domain, it goes left and right forever, so negative infinity to positive infinity. The range, it never goes below that x-axis, so it starts with 0 and it goes up forever. So the x-intercept hits at 0, 0 on the x-axis, and the y-intercept is also at 0, 0. And I would say that it has an extrema right there at 0, 0, and I would call that an absolute minimum. Okay, so it's increasing on the right side, so from 0 to positive infinity. It's decreasing on the left side, so I'd say negative infinity to 0. We'll go ahead and say none for discontinuities in behavior. So the left side is going up, right side is going up. As x approaches negative infinity, left side, f of x approaches positive infinity, up. As x approaches positive infinity, the right side, f of x approaches positive infinity, up. Okay. Alright, so cubic functions are dealt with in Math 3, not a lot. So a cubic function looks like this. It's just a cube root. Looks kind of like a roller coaster a little bit. Your domain is from negative infinity to infinity. Your range is from negative infinity to infinity. Your x-intercept hits at 0, 0. Y-intercept at 0, 0. This one, I'm going to say none, because you don't have any relative max, relative min, stuff like that. It's, if you're reading it from left to right, it's always increasing. So from negative infinity to positive infinity. So that would mean it's not decreasing. I'm going to skip in behavior just because it's getting on my nerves. And there are no discontinuities, no holes or breaks. Okay, so then a radical. And you also call that a square root function. So however you want to think of it. So it's going to look like this. It looks like a little heel. The domain, you start with, let me do a bracket. Start with 0 and you go to infinity. The range is the same. Start with 0, go to infinity. The x-intercept, it hits at 0, 0. Y-intercept at 0, 0. At 0, 0, you have an absolute minimum because it never goes below that. It's always increasing. Well, not always, but it starts at 0 and then it goes to infinity. It does not decrease. I'm going to skip in behavior because I'm annoyed with it. And it has no discontinuities. Alright. Then we also did rational functions. Sometimes they're called reciprocal functions. These are not my favorite. They look like these crazy curves. Ugh. Okay, so the domain for this one would be from negative infinity to 0, and then from 0 to positive infinity. But I think an easier way to write that would be if you wrote it like x not equal to 0, because it's anything but 0. And then the same thing for the range. I would say y not equal to 0. So I wouldn't even try doing interval notation for that one, and you wouldn't see that on a quiz or a test. You don't have any x-intercepts, and you don't have any y-intercepts. And you don't have any extrema. Increasing, none. Decreasing always, but you can't include 0. Okay, so I would say from negative infinity to 0, and then from 0 to positive infinity. We're going to skip in behavior. And this time you do have a discontinuity, because notice you can't hit 0. So I would say discontinuity at x equals 0. The reason x cannot be 0 is if you look in the original function, remember back from elementary school, 0 can never be on the bottom of a fraction, so that's why x can never be 0. And because x can never be 0, y could also never be 0. Okay. Exponential, you do in Math 1, Math 2, and Math 3. So it's some number to a power of x. I'm just going to pick a 2. You could pick 3, pick whatever. The domain is going to be from negative infinity to positive infinity. Your range, it's always going to be bigger than 0. I'm gonna put a bracket because you could equal 0. Alright, your x-intercept's none. Okay, I changed my mind about this. Let's just do a parenthesis. Because you're never gonna hit the x-axis. That's right. Y-intercept, this one hits at 0, 1. Extrema, none. It's always going to be increasing, so it's never going to be decreasing. We're going to skip in behavior. This one does not have any breaks or holes in the graph. Alright, logarithmic. So we did these in Math 3. So these look like they have the word log in it and an x. For these, the domain is going to be anything greater than 0. Your range is everything. So for this one, the x-intercept is at 1, 0. You don't have a y-intercept. Extrema, none. It's increasing from 0 to infinity. It's not decreasing at all. We're going to skip. And there are no discontinuities. Alright. So this one probably going to be new for you. It looks like this. You might see it's like a double set of brackets. It's kind of like a piecewise function, but we call it a step. It looks like stair steps almost. These are a little weird. Your domain is from negative infinity to positive infinity, because you do have all the x values. Your range is all integers. So I wouldn't even put this in interval notation. I would say y is all integers. So, and what I mean by integers is I mean whole numbers. And I just spelled integers wrong. Integers. Okay. My x-intercept hits at 0, 0. My y-intercept hits at 0, 0. There are no extrema. It's increasing always. It's never decreasing. Do not care. And there are lots of discontinuities. So I would say there is a jump, or you could say step, every integer. So those are a little weird. Okay. So sine functions. So we did look at sine functions a little bit in Math 2, a little bit more in Math 3. So these are those weird waves. So your domain hits everything. Your range is only between -1 and +1. Your y-intercepts, your x-intercepts are going to be 0, 0, and then also like different, like it's going to hit here and here and here. So that's why I'm going to put plus k times pi, so some number times pi. So plus 1 pi, plus 2 pi, plus 3 pi, blah, blah, blah. Okay, your y-intercept, definitely 0, 0. We're just going to skip this right now. Let's just not. Because we were going to go back over trig a lot more in some future units. I'm sorry. Cosine. So remember, it looks like this. Let's just not talk about the key features. Just remember that these are your wave functions. Alright. And then here are some little drawings to help you remember some stuff. Okay. So, I know that's a lot to get back in your head. Don't worry about the trig functions so much. Just remember that those are your wave functions. the step function was probably the only one new that you've never seen. Everything else should have been reviewed. If you're having trouble with these key functions or key features, go back and watch some videos again, or ask me for help, or watch the extra videos I put on, stuff like that. Alright, I'll see you guys later.